Hello everyone. I hope you can hear me. I know it's a weird audio setting here. Thank you. All right, I see thumbs up. Let's get started. I'm Gauri Shankar. I am a data engineering manager for Doordash. Here joining me is Chow, who's also a data engineer for Doordash. Today we're going to talk about something on Customer 360 and how it's evolved into an entity management framework. Before we get started, I want to get a quick show of hands. How many of you have used the Doordash app in the last 1 month or so? Quick show of hands. Awesome. Have you ever wondered how is it able to figure out a juicy promo for my next meal that you're thinking that you want to order, or your next grocery delivery, right? There's no real magic behind it, but it's primarily from a data-driven approach. So let's get started. All right. So what we're talking about here today in the next 20 minutes, I know it's the end of the day, but bear with me. We're talking about the journey of building a Customer 360 and the benefits of that, the challenges we faced, and then how it evolved into entity management framework. So what we are talking about is Customer 360 and the evolution of how it became entity management framework at Doordash. We, at the end of this talk, we want you to be inspired. Let's say if you're managing customer data, right? We want you to start imagining what it would be if you could have your own Customer 360. If you already have a Customer 360 in-house, we want you to understand and be inspired to build an entity management framework. And we'll talk through what an entity management framework is. And if you already have something like this, like an entity management framework, we want you to talk to us about challenges you're facing and what you're planning to build in the coming weeks and months. We would love to talk to you about it. All right, so what is a customer profile, right? Why Customer 360? A customer profile, what it enables is a deeper understanding of customers across different engagement surfaces on your app. So it could be app sessions, it could be orders, it could be understanding where the consumers are engaging in the app. Are they engaging with campaigns? Are they getting notified? How many touch points do we have for the customer on a weekly basis? Are they subscribing? Are they using a lot of understanding promotion usage? So stitching together a lot of this data, which is analytically derived, right? Which is more deterministic. You can use analytic queries to derive it, and stitching that together with ML-derived data, machine learning-derived data sets. For example, propensity to churn. Like you want to understand that the customer is most likely going to churn, or cancel the subscription, or you may want to know the affinity to a certain cuisine, coming from Doordash, right? So if you want to have a clear view where it's completely stitched together based on common definitions, that is what a customer profile is, right? So we have to create this customer profile, right? And also make it available for all our data consumers. So that's the goal of Customer 360. Let's step back a little bit. That way we understand the challenges we faced before we had Customer 360. So if some of this resonates with you, think through what your current situation is if you're managing customer data, right? So we had monolithic dimensions of customer, and we had multiple teams. Since it's so easy to build your own customer data set, multiple teams were building it, and they were building it based on their own definition of customer data. So what that does is everybody has their own version of customer data, right? And they're using it for their own use cases. But what happens is when one team figures out that, oh, my definition is incorrect, it doesn't align with the organization definition, and that is one thing. And then there's no clear guarantee of freshness of data. So you're gathering data from multiple different sources: subscription, promo usage, orders-based data. So you don't know whether the data is fresh or not. There's no clear SLAs. You're not meeting SLAs. There are no SLOs that you guaranteed. And what it leads to is fragmented customer signals. So if you want to power the top use cases like this, for example, personalization, if you want to do targeting, if you want to do fraud detection, and if you want to do accurate measurement of your campaign performance, you are not able to reach and get these use cases rolled out across the company where they're all using the same customer definitions. So what we did was, when we understood the challenges and we said, okay, let's goal for these use cases. Let's make sure these use cases get the customer data that it needs, and that way, we are able to trigger the right campaign, whether it be email push or SMS at the right time, right? And then build audiences. That way, you reach the right customers, and then once you reach them, you're personalizing the feeds that they're seeing in the app based on the same consumer data, right? And then also detect fraud as it happens, and not wait for 24 hours to figure out that, okay, the fraudulent activity is already transpired and we need to recover from it, right? So these are the key use cases we targeted, and we said, okay, let's build out Customer 360. Moving on, this is the architectural diagram of the entity management framework that we started off with, where you can see that the customer profile is one part of it. It's on the left-hand side. So consumer profile is created within the entity management framework. So what is entity management framework, right? So this is a framework where Customer 360 is just a tenant, right? So we are using reliable sources of information. We see consumer here, we see dasher information, we see merchant information. So all of this built on highly reusable components, which are needed to create any profile, not just consumer profile, not just customer profile, but for any profile, right? So we learned our lessons from building Customer 360 using these components. For example, data quality, attribute catalog, data governance, and the metadata for the entity, right? So these components, what we learned that every entity requires the same component. Why not have it reused and build an entity management framework, right? So once we build it, the tables that you see here, they're all in Delta Lake. They're built of Delta Lake format, and of course using Spark Compute. We said, okay, now we have built it, what do we do with it? So we have to activate this data, right? So when we activate this data, the data consumer is demanding, saying, I want this data in a certain place. Some consumers say, I want it for measurement. So I want it in data platform. I want it in reporting. Some consumers say, I want it to activate so that I can run a campaign against it. I want to reach and create audiences. So we sync it to an audience targeting system. We also created an online cache. So the product engineer in Doordash says, I want to create a page where I want to glean the customer information, and based on what the customer information says, I want to create a certain button. I want to create an action on the product, right? So that is using online cache. And then, of course, ML features for ranking algorithms and clean rooms, right? So the same customer data, same profile data is synced to multiple serving layers. So that was the whole idea of entity management framework. With that, we also learned what you can see over there is attribute catalog being exposed in Data Hub. Data Hub, right behind us, it is a discoverable tool. So basically, you discover what is a high quality data set, not just what a table is, but also what is the attribute within the profile. So you want to discover that using a search feature, right? You want to search and find your attribute. That way, it's not based on ask systems, but it's a very simple UI, right? So we made it discoverable. Moving on. So we covered some sort of the entity management framework. So this is nothing but just to elaborate a little bit more on what an entity is, right? Customer, definitely an entity. For DoorDash, Dasher, you may have know the driver who drops off your food. That is an entity. But also we expanded more on this. We said customer store is a multi-key entity. So customer business is another multi-key entity. So what it does is customer store is, it tells you, okay, what is my customer preference for, so let's say McDonald's, customer's preference, let's say for Wendy's, right? That way you're understanding by a certain restaurant, by a certain store, the preferences that the customer is taking. And then when we say customer business, if he prefers Pepsi, if he prefers Coca-Cola, right? So that is brand affinity that we can glean from behavior on the DoorDash app. Right? So the other thing that we built out is a streaming framework. Streaming framework is to create real-time attributes. Real-time attributes are nothing but, as let's say you sign up for the subscription on DoorDash, it's called Dash Pass. So if you sign up for Dash Pass, you want to be presented with X number of offers, and that has to be start coming in your email the first day, and then within 7 days you'll get another offer. That way it takes you on a journey once you sign up for a subscription, right? So we want to start that and activate this campaign right after the sign up happens. So that is why we need a real-time frame. And the way we enabled it using the Spark streaming, and it was tightly coupled with the entity management framework. So it is basically creating real-time data and expanding on your entity. The other thing was online serving. So not just serve in your data lake, right? So that's not enough. So we have to make it available in online cache, where it's available for gRPC endpoints within your company. So once you expose this becomes a very powerful tool for your product engineers who are creating the app to integrate, where suddenly they have customer information, which is gleaned from looking at historical data sets and ML-derived data sets, which is very hard to get for a product engineer. Moving on. Yeah, so as we scaled on this framework, right, the scale came quick. We started with hundreds of attributes, became 1,000 more than 1,000, right? We'll share the numbers later, but what happened with that was ownership was very unclear, right? And also the business logic used to create the attributes, there needs to be a common definition, and there needs to be SMEs who are looking at business logic and say, yes, this is the right logic, right? That's how you build trust in your data set. Otherwise, if somebody builds, they leave the company in 3 months, then they leave, but nobody knows why this logic was used, right? So that was a common pattern. And also, the platform team who maintains the framework, they are not aware of the logic. You can't ask the platform team for logic. So what we did was we created different ownerships at different levels. So domain-based ownership, attribute ownership, and platform ownership. So we said platform owners don't have to worry about business logic. The domain owners don't need to worry about the platform specific. So we divided that, and we codified all of this in GitHub, right? And where we created GitHub teams, and we are managing scale with this, where we categorize the attributes into domains, and each domain is assigned a certain SME or list of SMEs, and only they can approve changes to the attribute. So that's something. Moving on, and of course, this is, I don't know if you got the hint already, this is a declarative framework. We want to enable quick authoring using self-service, right? So folks who are familiar with SQL, all they need to know is how to create a SQL to generate an attribute. Once they can do that, the rest is pretty easy. Assigning data quality checks that you can see, and then assigning compute, as well as refresh. I wanted to refresh every 1 hour or every day, or every 5 minutes, right? And also establishing dependencies. So once you have this written out in a simple YAML-based config, that's it. You don't need to figure out and have competency in building pipelines, making sure it's reliable. That is guaranteed by the platform, right? And then, of course, the few things that you see there based on reviewers, So review is based on the domain. So if you're creating a subscription-based attribute, subscription-based SMEs will automatically get pinged and become reviewers for your attribute logic change. So once you have that, you're getting reviews from, you don't need to know who's the SME for subscription. That is all codified in GitHub. Moving on. All right, as we scaled, we understood that discoverability is a challenge. We scaled to, as you'll see numbers, we are more than 2,000 attributes across 20, 30 profiles, right? So we are managing a lot of data. It's as good as managing 3,000 tables, but we want to make it discoverable, right? So we used Data Hub to integrate. We created our own catalog in the framework, and we integrated with Data Hub. What it does is it tells you what is the right attribute, tells you the description, what is the lineage, how did the attribute get created, what were the data sources that were created, and what was the recent freshness on it, quality checks that are available against it, right? So that way you suddenly, if you're a data consumer, you get confidence saying, oh, this is the data I'm looking for, I'm going to go use it, right? And of course, anomaly detection as well. A little bit more detail, going into one level detail on how this is created. We don't create attribute like one job in Databricks or any other Spark system does not create one attribute, but it takes in an attribute set. It takes in a set of attributes and creates it, but basically it pulls it into the bucketed merge, the system that we have, and that's how it manages concurrent updates. So you're going to have concurrent updates. This is a managed way to solve the concurrent update problem, where you having data coming into the profile and constantly getting updated at different points in the day, right? And then we used Kafka to sync it to the online cache. So online cache, we used Cockroach database, right? And built endpoints on top of it, where you have sub-second retrieval. So it is very, very low latency, 200 milliseconds retrieval speed, as well as very high QPS. So you're handling very high QPS and sub-second latency when you read the data, right? So that is using the power of online cache. And all of the ones on the left-hand side that you see is all using Delta Lake tables and Spark Compute to push the data across. And we made it make sure that cost attribution is in place. We are providing cost to the right teams who are calculating the right attributes. Right, and of course, as I mentioned, you have different refresh cadences. We had all the variations and various sync destinations. Once you create the profile, you need to make it available where the consumer is. In our company, we have consumers all over the place. We have needed for CRM targeting, paid media targeting, online cache, audience creation, as well as data warehouse, right? So we make it available, and it's part of the framework, right? And this took, this was not a two-week sprint or a 4-week sprint. This took a while, and we learned the highest priority needs from our customers, right? And then built on top of it, right? So we have almost now, towards the end, we have almost 40 internal services uploaded, and we moved, as you can see, we started with Customer 360, and we moved it to X360. X is any entity, so it's entity management system. So that's what entity is, right? So this is the business impact. We have more than 2,000 attributes available, and 2,000 campaigns, and 40 plus microservices integrated internally. Right, what's next? What's next is as we scale higher and higher, we want to tier the attributes. That way, not every attribute is high quality. We want to give high quality attributes, data contracts backing, right? Where we have data contracts with our data sources. And that way, experimental attributes are also welcome, right? If it does not meet the quality criteria, it's lower tier. But if it has a very strong data contract with the source producer and SLAs, it is a higher tier. So that's what is next. And of course, AI-powered attribute authoring and discoverability, right? So this is what is next. And yeah, we are at the end of the session, but I did want to thank our Databricks team who worked closely with us. We have Jay and Michaela. Thank you so much for working closely with us through our journey. And of course, we have our X360 team, our data leadership at Doordash who supported us through this journey. We would love to hear if you have questions. We can take questions now.